Hello everyone. Today we are in the last section of our data communication section. In this session we will discuss about X25 standards, sonnet, frame relay, ATM and etc. Now moving on to the next, the first topics of our discussion is X25. X25 is a protocol which stands for WAN communication, which is WAN communication, and it defines how to connect between user and devices, and the network devices are established to maintain. It is typically used in the packet switch network, which is PSN network. A common carriers such as telephone companies are used in X25 developers. In X25 it is used for circuit switching, so in if the one line is busy, so no data communication can be occurred in that line. X in X25, the data terminal equipment, which is DTE. Here the examples are terminals and personal computers, routers, which are known as DTE, and DCE, which is data circuit transmission equipment, which is short form as DCE. Those are used as the routers in the WAN section. So the router is known as DCE and endpoints are known as DTE in X25 section. The structure of X25. Here are three levels. One is the physical level, the data link layer level, and the network level. The physical level, we have X21, and in data layer section we have the frame layer, and in the network section we have the packet layer. In the network section we have the router. By this router we can generate the path. In the data link layer section we have the switches which can build the table of MAC address and IP addresses. In the physical layer we have the hub section, where the hub generally and physically sends the data from one to another. So that's how the layer works. In physical layer it have just only IP addresses. In data link layer it have the MAC addresses, and in physical layer it have the routing paths. The advantages and disadvantages of X25 is given here. You can have a snap of this one. Now frame relay is developed the based on X25. Frame relay is better than the X25 because it works on the data link layer. The architecture of frame relay is given here. In the LAN section, those LANs are connected with a router, and this router are connected with several switches in that WAN connection, which is basically the frame relay network, and then moves on. In the frame relay section we have virtual circuit and switches. In frame relay layer we have two layers, physical layer and data link layer. Physical layer have no specified protocols with frame relay, and in data link layer the frame relay uses a simple protocol and does not support the flow or error controls in the data link layer section. The structure of frame relay is given below. Here are flags, address section, information section, and FCS. In this address field section we have the DLCI section, CR or comment or response section, extended section which is EA, forward explicit conjugation notification which is FECN, and so on. Here we have discussed about information fields and frame check sequence, which is known as FCS. The frame check sequence is used to check the errors. The advantages and disadvantages of frame relay is given here. The frame relay is used because it has lower error rate than X25. It is less expensive with having two layers, and it is higher speed than the X25. Now the sonnet or SDH. Here synchronous network using the synchronous TDM multiplication. The ANSI stands for is the call of synchronous optical network, which is the sonnet. The structure of architecture sonnet is given here. Here we have signals, devices, and connectors. In this session, we can see that we have multiplexing section and demultiplexing section. T's are all the terminals and R denotes the routers. Here, routers and regenerators are denoted by the R and T are the terminals. Here, ADM stands for add drop multiplexer. Then MUX is for multiplexer and DEMUX for demultiplexer. From this session, multiplexer to the first router, then router to router, and router to the ADM, which is add drop section, is known as sessions. And the combination of session before the ADM and after the ADM is known as a line. Those two sessions create a line and those three sessions create a line. The, the path is denoted from multiplex to demultiplex, which stands and is started from the multiplexing section to the demultiplexing section. The whole path is known as a path section. Now, devices. The description of devices is given here. Regenerators are used to generate the links and to increase the length of the signals. The AD multiplexer or add drop multiplexer are basically very important topics for your examination, because AD multiplexer allows to insertion and extraction of signals, and add drop multiplexer, that is ADM, can add SST coming from different source into given path, or can remove desired signals from a path, redirected it without demultiplexing into an entire signal. That means if the signal is low, then the AD multiplexer can make it up signal, and if the signal is down, then and if the signal is up, then it can balance the signal. So the AD multiplexer basically works as a transistor. Terminals are the last equipments, and the connectors here are session, links, and paths, which we have already discussed. The advantages and disadvantages of sonnet are given here. You can have a snap of this. Now our very important topics is ATM, which is asynchronous transmission mode. Asynchronous transmission mode is a switch wide area network based on the cell relay protocol by the ATM forum adapted by ITUT. The ATM architecture is very important for your examination question. Here we have the endpoints, which we can denote it by the UNI, which is user to network interfaces, and network to network interfaces, which are NNI. In this section, we have switches. In UNI section are connected with next switches, which are NNI, that means the network to network interfaces. Then the between switches are connected as NNI, which is network to network interfaces, and network to network interfaces are when it is connected with the endpoint, which are users, then it will call the UNI. So in this section we have 3 UNI. You can remember that when it is connected with the endpoint is known as the user network interface, and when it is connected from switch to switch or another networks, then it is called the network to network interface, which is NNI. This architecture is very important. Now the virtual connections. In these connections we have TP, which is for transmission path, which is the main path, and VP is for virtual path, which is the small paths, and the virtual circuit VC is the cell network, which are based on the virtual circuits. In this virtual path identifier, which is VPI, and virtual circuit identifier, which is VCI, in the cell section we have headers which conducts with the VPI and VCI with 5 bytes, and payloads are with 48 bytes. Here the total byte of section is 53 bytes. Now the connections. Here connections are conducted with PVC and SVC. PVC stands for permanent virtual circuit connections, and SVC is for switched virtual connections, which are not permanent, and PVC are always permanent. The diagram of ATM layer is also very important. In this diagram we can see that we have AAL first, then we have the ATM layer, then we have the physical layer. In this physical layer section, the routers and the linkers are all are connected. In the ATM section is just right after the physical layer, and after ATM layer we have the AAL section, which is the application adaptation layer. ATM layer provides the routing and traffic management and switching and multiplication services. Physical layer like Ethernet and wireless LAN or ATM cells can be carried by the physical layer carriers. The advantages and disadvantages are given here. Now the ISDN, which is Integrated Service Digital Network, which is for the mobile communication. Here we have two types of ISDN network. One is BRI, which is Basic Rate Interface, and another one is Primary Rate Interface, which is known as PRI. Here the Basic Rate Interface, it have 24 24 bit of channels with one dimensional channel, and in primary rate interface it provides the 23 byte of channels with one dimensional channel. In ISDN architecture we have some architectural devices, and the architecture will look like this one. You can have a snap of this one. Here are some terminal equipments which are known as TE1 and TE2. TA stands for terminal adapter. Here network terminals are known as NT. Here we have NT1 and NT2. The other stands for RSTU interfaces are given here. The advantages and disadvantages of ISDN is given here. You can have a snap of this. These advantages and disadvantages are important for your exam point of view. RS232C, it is a standard where RS232C is a long established standard that describes the physical interface and the protocol for relatively low speed serial data communication between computers and related devices. It has some important limitations, that it is not suitable for distance more than 50 meters, and it has a maximum bandwidth of 20 kbps. Here is a short note on EIA 232D standard. You can go through them. EIA stands for Electronics Industry Association, which is accept the standard, which ID number is 232. The last section of this lecture is the modem. The modem stands for modulation and demodulation. In this session, the sender side, the data is sent as a signal, and then the modem works on it and generate it as a analog signal. From this DA converter that converts the signal from digital to analog is the work of modem, and then it will transform. After, when it is closer to the receiving side, the demodulation generates the digital signal from this analog signal, which is the AD converter, is the work of demodulation. Here are some types of modems. 56K digital modem, CSU and DSU, which is symmetric, and the cable modem, which is asymmetric, where download speed and upload speed are defined. In ISDN modem, all are digital signals and the speed is 128 kbps, and in DSL modem, speed simulation to the cable modem and all signals are used in the digital. You can have a snap of this table. Description of the 56 kilobyte modem is given here. This is not very much important for your exam point of view, but you can read this. That's for today, and this was the last lecture of our data communication. See you in the next lecture or next series. Thank you. Till then, goodbye.